My name is Jamie Sambauer. You're in Advanced ISE, Architect, Design, and Scale ISE for Production Networks. This is a 3,000 level course, so we're going to go pretty technical pretty quickly. Again, I'm a principal architect. Just to give you a bit of background, I work on the global security architecture team at Cisco, so my day-to-day is working with large customers around the world and typically it's more than one product, which ISE falls into that category quite a bit, because a lot of our larger ISE customers start to become the key or heart of a lot of the security architecture. So whether it's ISE plus a firewall, ISE plus another security solution, we do see ISE as kind of a key cornerstone. Prior to Cisco, I worked for a Cisco Gold partner. So a lot of my day-to-day was deploying this technology, trying to make it real, and working with large customers to try to get it deployed in a meaningful way. I'm from Melbourne, Florida, so not too far away, but I am based near Orlando, near Kennedy Space Center. I get to see rockets go up, go see Mickey Mouse, those kind of things. A little bit about today. So if you didn't read the abstract, we're going to focus in on how we scale ISE out with load balancers, with tuning, with optimization of ISE itself from a deployment point of view to make it scale and work better than it does out of the box. We do have a smaller group here, so feel free to ask questions. Let's keep it interactive. If you have a question that is not related to the slide, feel free to throw it out there. This isn't recorded, so we're happy to kind of go off book a little bit. There is a ton of content in this deck, so please download it afterwards. Literally, it's about 578 slides that are built in here. So we're not going to be able to cover everything that's been built around this Cisco Live session over the years. There are multiple pre-recorded versions that go into certain areas a little bit deeper than others, but we like to leave all the slides in there, so as you're looking at this as a reference in the future, it's got all the details behind it. So where I might be in a section and present one slide, there's probably 10 slides behind it that actually support or go into more detail along those lines. I will be joining the WebEx Teams room to answer questions after the session. So if you have questions that you forgot or you start reviewing the PDF and want to ask questions later on, feel free to put them in WebEx Teams, or you can reach out directly. Where can I get help after Cisco Live? I have references throughout the presentation. So you're going to see a lot of links in there to give you the direct documentation. But also, if you're not familiar, there is a public-facing ISE community that allows our customers to come and interact with people like myself, but also the direct business unit. So some of the technical marketing engineers and product managers also look at that. So there's ways that you can get feedback. Hey, I'd like to see this feature in the product. I wish it did this. Or how can I accomplish this use case in ISE? From an agenda point of view, we're going to start off just going a quick update on software and hardware, kind of the latest and greatest with 2.6 and the 3600 appliances. Then we're going to get into some ISE design, sizing and deployments, bandwidth and latency. We'll get into how to scale individual services, and then close it out with some high availability and monitoring. So hopefully all of you have heard by now, because it was released in February. ISE 2.6 was released back in February. There were some pretty critical back-end features with ISE 2.6. Just to give you an idea, this will be a long-term release that we focus on keeping around for a while and keeping support up. If you're not familiar with our release cycle, the even-numbered releases are longer-term supported releases, and the odd numbers are shorter-term releases. So for example, a lot of people will ask, well, what happened to ISE 2.5? Well, we wanted to make 2.6 a long-term release because of the new appliances, as well as some of the features like government certifications and other things that happen with that version. Couple key features that we put out there with ISE 2.6. One was IPv6 for management. So previously we had a lot of IPv6 features for the data plane and connecting clients up. We've got more and more customers that are doing native IPv6 networks, and we wanted to make sure that they could manage ISE and work with ISE from like an AD point of view, DNS point of view. All of that now is supported within ISE 2.6. So if you do have a native v6 network, 2.6 is the version that's going to be the most helpful for you. Another thing that came up quite a bit, hopefully everyone in the room does know ISE. Basic level of knowledge, good, good, good. With 2.6 and previous versions, we have a lot of organizations that are starting to interact with ISE in an automated fashion. So through API calls, and one of the big requests that we got was being able to authenticate those users outside of the ISE internal admin database. So in 2.6, we now allow you to authenticate REST calls using Active Directory. And the same thing goes for admin CLI. So when you SSH or go to the console itself, before it was only internal users, now you can actually reference Active Directory and the groups associated with your administrators to authenticate via the CLI as well. The other thing that came up was for posture. One of the use cases that we ran into a couple times was if I have a machine and it has multiple network interfaces, it's going to have multiple MAC addresses. Well, ISE uses session ID and MAC address as a key to do things like posture, web redirect, other services. And what was happening was I could authenticate with my laptop in the morning on wired. As soon as I took it out of the wired network and went to wireless, I'd have to do another posture assessment to get access to the network. So with UDID, this feature that we actually added, it allows us to key off of a unique identifier. So when my laptop goes from wired to wireless, I no longer have to re-posture assess. It knows that I just went through it 15 minutes ago. Question? Correct. So in order for us to generate that UDID, it's focused on that posture feature, and today it's AnyConnect only.
Yeah, but they don't have to have an MDM though. It says MDM prerequisite
So,
MDM, but MDM is not required.
So for mobile devices, the same way we would do posture and use AnyConnect to generate that UDID, if this was a mobile device and had multiple MAC addresses, multiple interfaces, we would leverage MDM to generate that UDID, which most MDMs have always actually generated a UDID for us. Now we're able to key off of that MDM's UDID versus MAC address for those sessions.
So that's a requirement
for mobile devices to get this type of persistent connectivity with multiple interfaces. I believe it's on the roadmap, but hit me up afterwards. I can double check for you. The other thing that came up quite a bit with posture, and it goes to that end user use case, is an increased grace period for posture. What we were running into is I would come back after a long holiday, bring my machine on, go through posture assessment, and it'd be 2 weeks worth of updates that I needed to go through. And this increased grace period allows for better end user notification, doesn't require them to update prior to getting on the network, gives them a little bit more time to get settled, get the machine up to date, etc. Now, the reason why this is important is I always joke, it's not up to the end user to update their machines. If they go on vacation, they come back, they turn on their laptop, we kind of expect the IT systems like JAMF or MDM or Microsoft SCCM to get that machine up to date. So the goal here is also not only focused on the end user updating, but giving IT systems time to update that machine before restricting that laptop or workstation with their access to the network. The other thing that hopefully everyone saw was with AnyConnect 4.7, we completely changed the way posture looks and feels. I do like that ringtone, get me excited. So AnyConnect 4.7, and obviously we've released 4.8, actually has a new look and feel. And so the previous version is a little bit ugly. The newer version has a better feel from an end user point of view. The messages are more customizable, as well as the way we do remediation here kind of makes a little bit more sense. So just a better look and feel overall. Over the past couple years, we've seen a lot of the larger customers look to increase the presence and features of ISE. And so one of the biggest features is trying to do network segmentation. And one of the challenges that a lot of customers had was as they would look to roll out TrustSec or segmentation to their networks, some of the systems or network access devices or NADs wouldn't actually get the updated version of the policy. And so this was a pretty big request from a lot of customers is help me understand how that TrustSec or segmentation deployment has gone and verify which NADs have the updated TrustSec matrix for enforcement. And so this feature actually allows us to report on every switch or router or device that's downloading that TrustSec matrix for segmentation and verify that it has the latest version. So I'm not having to worry about, hey, did half of my network not get this latest policy and I'm missing packets? So this was a pretty big feature for a lot of our larger segmentation customers. One other feature that goes to kind of the moral of today's session is this lightweight session directory. So one of the things that was happening was as the architecture was being scaled out, messages were going over syslog. If that PAN and M&T went down, there wasn't a large buffer to save those messages. And so one of the benefits of adding this message bus as a part of the session directory is even if PAN and M&T go down, we're able to propagate session details from one PSN to another. And this was really the start of an infrastructure release. So you'll see in our next version of ISE, this infrastructure will be used more and more for session replication and increased scale. Now, if you're running an existing version, from an upgrade path point of view, to get to 2.6 in the new software, you can go from 2.1, 2.2, 2.3, 2.4, all directly up to 2.6. From a hardware support point of view, just like 2.4, you're going to be running only the 35XX. So if you haven't made the effort to upgrade hardware recently, 3500s, 3600s are the supported hardware for the 2.6 release. Now, obviously, we're going to talk about virtual machines quite a bit and how that plays into the hardware requirements. But from a physical hardware point of view, those are the two appliances. Now, I put this in there for reference, and I also figured at 8:45 in the morning, we would put it up on the screen for 2 minutes, and at the end of the session, there's a test. No. So everyone should be familiar with this slide, which basically illustrates all of the ports and services that ISE uses for intercommunication. It's not one that even I would like to try to memorize. It is in the formal documentation. It's in almost every advanced ISE session that you would attend. The key thing here with 2.6 is some of the additions. So that lightweight directory service, some of the additional profiling services all kind of show up here. And in that 2.6 documentation, we're going to show you more of the Delta ports and protocols that are associated with the node communication. Now, At the same time that 2.6 was released, we released the 3600 appliances. They are based on the M5, UCS M5 series appliances. Now the first piece of customer feedback we got, which was valid, was, hey, these are great, you've end of saled your 3500s, but now if I want to expand my existing ISE deployment, I've got to now upgrade everything to 2.6. And one of the conflicts there was 2.4 was, back in February, and still today, is the formal recommended release. So we haven't moved to 2.6 as the rubber stamp or the formally suggested release yet. And so what we forced, and through customer feedback like your own, we actually got 2.4 certified and supported on these brand new appliances. So if you are running 2.4, you need to add another ISE node. You can now run the new appliance with 2.4.
Would there be a reason why you want to strongly consider 2.6 over 2.4? Like maybe customers maybe want to go to SD access or something like that?
So the question was, would there be a strong reason to go to 2.6 versus recommending 2.4? A lot of it has to do with those features. If my customer was a native IPv6 shop, I have to go to 2.6. In Greenfield, we find a lot more customers will start with the latest version just for new deployments. But in a brownfield environment, we do, unless you have a feature or bug that's fixed in the next version, I try to recommend to stick to that suggested release. And that suggested release is a combination of both pre-sales, customer feedback, TAC feedback, and development feedback to actually get that suggested release marker within CCO. So typically, unless there's a dire need for one of the new features, stick with the suggested release.
Let me just add on to that question. For customers that are considering SD access or starting to prepare for it, 2.4 supports all SD access?
It does. There are some new features with 1.3 or 1.3.1.1 within SD access that does require 2.6 features. And so you do have to look at that matrix. And if you missed the question, it was for a customer that's looking at software-defined access or SDA, what version of code should they go to? And the answer was, it depends, right? If it's a 1.3 deployment of SDA and DNA Center, then 2.6 is going to be the recommended release, and that's very public on the matrix for DNA Center. If it's a previous version of DNA Center, then 2.4 is, with the latest patch, is the recommended. But great question. Hardware-wise, you will see we kind of added a new line, which is going to help us quite a bit. So previous to this, we would have a 3515 and a 3595. What you'll see with the new 3600s is we've actually increased scale and added a third appliance. So 3595 actually migrates over to this 3655, which is a medium-sized appliance. And the new style hardware is this 3695. And we're going to get into all the nitty details around how we can size. But the key number to see here, which is this new number of 100,000 endpoints supported per PSN. Now, as I mentioned, 2.4 is still the recommended release. And because of that, we focused on making sure that we could run 2.4 on these new appliances. So if you're out deploying or even in some greenfield environments for large scale, 3600s, 3500s can all run that 2.4 code. The key note that's in here is you need patch 9 or greater. So if you have an existing 2.4 deployment and you want to add a 3600 to that 2.4 deployment, make sure that you're at patch 9 or greater. As you can see, September 30th, we released patch 10. I don't remember whether in the last month we've put one out additionally, but patch 9 is the minimum to be able to run 2.4 on the 3600. Now with these 3600 appliances, the increased scale kind of comes in a couple places. The two that are really exciting for me, one is this small HA deployment. So one of the things that we got a lot of requests on was, hey, I've got 22,000 endpoints on my network, and now I've got to go to a 4-node ISE deployment. So with the new 3600 appliances, we're able to scale up to 50,000 endpoints on a 2-node deployment, which is a good increase. And what we find is a lot of our ISE customers in that mid-market, 50,000 and below, this makes it much more simple to get up, running, maintain, et cetera. The other number that has increased quite a bit is going from a total of 500,000 endpoints up to 2 million endpoints with the 3600s. Any of you all have 2 million endpoints? Over 1 million endpoints? Okay. So this number is probably a little better for the room than that 2 million. So we're going to keep coming back to this subway map. And this subway map is kind of a layout of our agenda. There are going to be some spots that I'll skip through. For those of you that weren't here in the beginning, all of the slides and all of the sections have additional details in the PDF. So make sure you download the PDF as well, and you'll be able to see the additional technical details. This slide deck actually has about 578 slides in it. So we're going to start with ISE design and kind of go along. Just as a quick review, node types. Everyone should hopefully be familiar with what PAN, MNT, PSN, PXGrid controller means. From a large deployment point of view, these node types, when we get into scaling, matter quite a bit. Everything can run in a single host, as I illustrated and as hopefully you all know. From a review standpoint, we've got traditional architecture. Endpoint talks to network access devices, or NADs. NADs are going to communicate with our PSNs. PSN's going to be working with our admin or PAN for configuration. The PSNs also communicate directly with external services like Active Directory for authentication. And MNT is all about logging all of the data associated with the deployment. Now let's take a few examples. So a basic 2-node deployment that's redundant is going to kind of look like this. All-in-one, primary admin, primary monitoring, primary PSN, and PXGrid all running on a primary and a secondary node. Now, this doesn't say primary, secondary, because in this deployment, this can be active-active from a PSN point of view. So both policy services engines can actually respond radius requests and take authentication simultaneously for load sharing. Now this deployment, as I mentioned, goes up to 50,000 endpoints. This is new with those 3600 series appliances. Now as we look at scaling out that 2-node deployment, you can see how the individual hardware does matter for scale. So if you're running the small 3615, it's only 10,000 sessions. 3655, or that middle appliance, is up to 25,000. And then from a large deployment, 50,000, you need those 3695s. And as you saw, there's a lot of memory, a lot of CPU, and a lot of disk space to make that work. Now, as we look at some of these deployments, we get into a lot of customers in this middle ground, which we call hybrid distributed deployments, which is not a fully distributed deployment. It's co-hosting admin, monitoring, and PXGrid on these 2 top nodes, and then adding PSNs as a part of the deployment. Now, some people go into this mode of operation even under that 50,000 count. Why do they do that? We'll look at it in a second. So one of the things that comes up quite a bit is being able to distribute policy services nodes to remote branches or secondary campuses to make sure that you have additional redundancy from a radius point of view. So 2 admin M&T nodes, a couple PSNs in the main data center, and then 2 PSNs in the other data center. Anyone see a problem with this?
Might want redundant admin.
Might want to move one of these over that way. So you can see pretty clearly when you start to look at redundancy, if this line in the middle gets broken, we can still do things like M&T. We'll get into how admin works in those types of scenarios, but when we're looking at redundancy, that matters. Another 2.6 feature that we added was the ability to have up to 4 optional PX Grid nodes. The total number of PSNs has not changed in a long time. So we're still at 50, so you can have up to those 50 PSNs. And we do see customers that grow that number out because they do want local PSNs at branches or local deployments. This 2 million number, I will warn you, the test was really .1x MAB only. So if you're doing additional services like profiling and posture and web redirect and guest, that number does go down, and you should be using the existing 500K number. So all services turned on, we're still at 500K for the deployment. If you're really focused on only .1x and MAB, then we can go up to that 2 million mark. Now this stuff does change quite frequently. So if you don't have this link bookmarked, it's an important one. cs.co/ICE scale brings you to this ICE performance and scale sheet that will be able to have all the updated metrics as things update. Oh, sorry, I messed up someone's picture. I went too fast. And you do have access to the PDF. So all of these slides will be in there, and you can see them later on, because there will be a lot of slides like that call out some important links. Now, as we grow out larger deployments, we look at things like the 500,000 maximum sessions or 2 million with a maximum of 50 PSNs. And when we look at the difference between 3500s and 3600s, hardware does matter. So in order to get to that 2 million mark, the amount of hardware actually is not too bad. So in 3500s, 18 appliances without redundancy will get you to 500,000. So 18 PSNs. And then with the 3600s, we're going up to 24 3695s to get there. Now, this is kind of a funny picture, and I think it's very relative to ICE, why design matters. And we see this way too often when someone's not talking to another person within the organization, design flaws happen. And in this design flaw, you've got a fire escape or a fire ladder going down into a high voltage electrical fenced area that is locked with a padlock. Fire does occur, things are not going to happen correctly. And the other one that most people can appreciate is not planning correctly, you end up in situations like this. Now let's take a few more examples of ICE design. One that's very common, starting out with the 2-node system, all-in-one services, and then we add a branch office. Now with that branch office, we might want to add that radius server for a PSN. As soon as I pull apart and add a PSN, I must actually run all PSN services externally to the admin M&T node. And this is one where it is a formal support statement versus what is technically work. Like we actually have caught a few in support and TAC cases where they're running like this, and technically this would work, but it is not supported. So as soon as you add a PSN to the deployment, whether it's at a branch or a secondary data center, you must have all the PSNs off of that primary and secondary admin node. This one gets the best of us, so beware. Now, the other thing that occurs quite frequently is we start to add a secondary data center. We move our PSNs out, so we have redundancy. We've got 2 PSNs in each. And now our deployment grows beyond the capability of the 2 PSNs, and we go to add a third. Now, this is great, but we have different load capability in data center A than data center B. So the next step is we want to add another PSN. And this is another one of those scenarios where the max for a hybrid deployment is 5 PSNs. So as soon as you want to add that 6th, you must now separate the PAN M&T from being a single system. So those are the 2 big gotchas. And the challenge is that technically, ISE won't tell you, like, hey, you're out of support compliance because you're running it this way. Think back to the fire escape coming down into a fence. If you don't think about these things, you will end up in a scenario that you call TAC, they're like, well, you're not running in a supported configuration. So this is kind of a key one, and I'm telling you it from experience. We've found a lot of customers that figure it out after calling TAC, hey, I can't run it this way, even though it's been working for a year. No, it's not formally supported or tested in that manner. Oh, went too fast. So platforms, hardware, and VM, this is another area that, from an advanced topic point of view, we run into quite a bit. And one of the key things here is the VMs for ISE kind of make a lot of our data center or server admins really mad at us. Why? Because we must do resource reservations and match up to the physical hardware for it to be formally supported and matched up. So when we size the production VMs, they must match kind of the physical hardware appliances in order to be formally supported and get that same level of performance that is recommended for that level of hardware. 2.0 gigahertz per core. Now, the funny part about that is I have seen a customer that had 1.6 and 32 cores on a single processor. Well, that's not formally at that same level, and those virtual CPUs do need to match. So if it says 2.0, it needs to be that level or above to be formally supported. The disk size is recommended depending on the persona. So for example, if I'm running a 3695 and it's acting as a PSN, 1.2 terabytes is okay. If it's running as an M&T node, it should typically have the 2.4 terabytes of hard disk space. The other thing that is important here is hyper-threading. And so with VMware, you'll see very quickly that hyper-threading being active is an actual option. And so what I have found is a lot of times the network engineer or security engineer that is deploying ISE is not the same person that's actually configuring VMware. So being able to have some of these slides so you can take back to them when they're building new VM resources is important. Another one that happens is in the new 2.6 version, we have actually changed the OVAs a little bit. We were getting a little bit out of hand where there was too many OVAs and you had to download like 5 of them to be able to do your deployment. Now we've reduced that number and added configuration options within the deployment. So when you go to deploy, you can select eval, small, medium size associated with that. And here are the 4 OVAs and how they break out into the different hardware. So if you're going to do an eval or a proof of concept, you're going to grab this SNS 3615, 3655 OVA. The difference between this one and the second one is all about hard disk space. So 200 versus 600. The 3655/3695, The medium and large profiles, it's all about the disk space, so 1.2 terabytes. And then the super MNT or large MNT is going to be the one that we want to use for that has 2.4 terabytes of disk space. Now the other thing that comes up is from a properties point of view. ISE is actually going to do some profiling to understand hardware profiling. Profiling is another topic, we'll get to that. But hardware profiling to make sure that the virtual machine has the appropriate resources to match the platform profile. And so this check happens quite a bit. And we need to make sure that the minimum CPUs, minimum RAM, minimum disk space does match. Otherwise, it will profile it lower. And this is a least common denominator. If I give a system 16 cores, but only give it 16 gigs of memory, it's going to profile it as a 3515. And everything within your scale and support maps back to that hardware profile. So just make sure you're doing the time and effort to verify that your specs actually match this. And one of the things it helps to do this before you even make a purchase. Like I find a lot of customers that if they were to understand this a little bit better up front, they would just buy an appliance because it's easier than having to do resource reservations at this large scale. Because when you think about it, 24 cores, 256 gigs of RAM, and potentially up to 2.4 terabytes, you're not going to get a lot of VMs, even on a lot of the modern ones, modern hardware platforms. So just think about that as you're doing the design. We're going to talk a little bit more on the super MNT on 2.4 and what that means, as well as with 2.6, how we've scaled that out. Now, if you're already in production and you want to see how we've profiled and detected the sizing of the existing virtual machine, you can actually run show CPU, show memory, show tech support will actually give us everything. And one of the key things here is that profile. So that profile is actually matching back to these platform profile names. And this is what ISE is using to do things like memory reservations and hard disk reservations, those kind of things. The other thing you can do from the CLI is do a show tech begin platform properties just to get to right where you need to. And you can also see in the admin UI the ISE profile that we've detected. Now the reason we've had so many slides, and I caution this, is I see this every day. Someone didn't do the VM correctly, and now we're in a performance, have a performance problem or an issue, and it all relates back to just getting that VM set up correctly in the first place. Now another thing that comes up is this whole concept of disk space or disk storage. Now, one of the things that you'll run into is in ISE 2.4, the maximum supported disk space is going to be 1.999 terabytes. So you're not going to be able to get at or above 2 terabytes with 2.4. And 2.6, that changes. And one of the reasons why that changes is we had to change the firmware option from BIOS over to EFI to support more than 2 terabytes. So if you do want to build that super MNT and match the 3695 specs, this BIOS setting matters. The other thing that I've seen happen quite a bit, and just a quick caution, is there is no auto resize of ISE partitions after we've done the initial install. And so you'll see a lot of people go, well, I just increased the hard disk space from 200 to 600 or 600 to 1.2, and it does absolutely nothing. So you add the disk space, add the 400 gigabytes, and it's not accessible to ISE. So the VM will see it, but ISE itself, from an application standpoint, doesn't have access to write to that space. So if you need to increase hard disk size, you have two options. you either reinstall or re-image using the ISO on that same virtual machine, or you have to redeploy a new virtual machine to increase that size. But be reminded, you can't just add disk space. It's not going to work in your favor. Now, some more disk guidance. No snapshots. They aren't formally supported, so it's not going to help you. Lean on ISE backups to be able to restore back to a certain known good state. Also, vMotion is not formally supported, and thin provisioning, thick provisioning, highly recommended for the PAN and M&T. So don't run into that issue where that disk space runs out because you've thin provisioned and it can't actually write to the amount of space that you've allocated. Read and write performance is a big one. If you can get faster disk, no one has ever complained when ISE is very fast at reading and writing data. So especially in the VM environment, try to use 10K or 10K RPM or above. Supercharge that with SSD, and then things like caching rate controllers and mirroring can help as well. We do have some hidden slides that will go into more details on how to spec out some of the hard disk space and things like that. Last and final warning, do not oversubscribe. Use the reservations. They are built into the OVAs. And I say that because typically, like I mentioned, it's normally not the network engineer that's building these images out. It's a data center or server guy. And the first thing they do is oversubscribe these VMs. Now, in normal VM functions, that's the reason why most people go to VMs. With ISE, we can't oversubscribe. We have to have the reservations in place. ISE needs to be able to use the full memory, the full CPU, and obviously be able to write to the full disk space that you've allocated. Now, this is the funny one. Customers with expertise may choose to disable and oversubscribe, but do so at your own risk. Just like this gentleman who's playing with the bear. I probably wouldn't trust to do it that way, but you can, but your results may vary. Now, one of the things that can help during this journey of deploying VMs is the ability to look and do a resource check before you ever install ISE. So you can actually run a virtual machine resource check while you're deploying an ISE node and make sure that it's meeting the specs of the VM platform. And then after installation, you can also do a show tech, begin disk performance, and see this. If we're out of compliance, the VM is out of compliance over a 24-hour period, you will get an alarm. So you will see an insufficient VM resource alarm on the ISE alarm dashboard. How many of you have heard of super M&T? Okay. So one of the things that has come up quite a bit is I'm sick of waiting. I need to be able to have access to logs. By default, we kind of started with a small, we got a medium, and now we're into the very, very large M&T to be able to do this super M&T. And it's really supercharging the specs associated with your M&T box. So for ISE 2.4, you can use the 3695 appliance or a VM with that large, or with that appliance or VM. It does require the large VM license to make this work. And the recommendation is to go to faster disk and up to that 2 terabyte space. And the biggest thing that we're trying to solve here is this message that hopefully you haven't seen too much of, but I'm a very impatient guy. No one likes to sit here and wait for reports to come back or live logs to happen. So you can see by doing that super M&T, the goal here is to increase the ability to see and have ISE UI respond for things like the live log, and the reports. And if you aren't familiar with that architecture, every time you go to live log or run a report, it's pulling that data back from M&T directly. So it's not on the pan, it's pulling that data from M&T, and that's why the resources on that system matter. So the last but not least, faster report, faster live log, collector throughput improvement, and major data reduction. So we do see quite a bit of benefits by going to that vertical scaling and the super M&T. So let's jump into bandwidth and latency. With bandwidth and latency, things haven't changed too much. We've got our global ISE deployment. Within that global ISE deployment, we're going to see replication and traffic between PSNs and the primary PAN and PSNs and the primary M&T, and also data to the secondary M&T. So logging data is going to both M&Ts simultaneously. Now the key thing here is starting in ISE 2.1, we still sit at a max round-trip latency of 300 milliseconds. So the network needs to be at 300 milliseconds in order for it to be formally supported. Do we have customers that have larger than 300 milliseconds? Yes, but it's not formally supported by TAC. So if you run into this situation where you have nodes that are above the latency, we can solve it in a few different ways. One, we focus on things like radius. So from the switch or wireless LAN controller going up to the primary radius server, the latency tolerance is a little bit higher there. So if you're familiar with radius in detail, normally you've got a 2 to 5 second timeout period for radius, whereas we're looking at 300 milliseconds for replication. Now, what do I do in this situation where I have greater than 300 milliseconds? Maybe it's a certain part of my deployment. And then I can look at different options. So in this example, we went from a single deployment worldwide to separating Americas and Europe and Asia and Australia. So the downside of this is this PAN and that PAN do not communicate. So whenever you make a policy change, you must make the change in one PAN and the other ICE cube, as we like to call it. Now the other option that is just as effective is being able to, instead of having local resource, send radius from our Asia Pacific and Australia sites up to the European PSNs. Now this is much more tolerant of the latency that we would see there. There is obviously a downside to this deployment where if these links die, we're going to lose authentication, authorization services. Now there's a couple options here. One option that we've seen done successfully is to put standalone nodes out in those remote locations so that the primary goes to the global deployment, and as a redundant backup, we have a local all-in-one system that can be pointed to. Now, in some cases, depending on the customer, they decide to make this as detailed as the global deployment, but in some cases, it's almost like local radius fallback on wireless, if you're familiar with that feature. It's not as feature-rich, but it's going to allow for that survivability scenario. The other option here is we can look at radius fallback in a different way. Actually, this is just showing what I just mentioned. Now, one of the cool things here is if the links die, it will buffer information, and you can use the standalone ICE nodes to the central M&T nodes to forward logs up. So for example, links die here, and we're starting to authenticate locally, we can send those logs from the local nodes up to the central M&Ts once the connection reestablishes. This bandwidth calculator hasn't been changed since ICE 2.1 because it doesn't need to be changed. It's still available publicly for you to get to. And again, you can see this in the slides and reference the calculator later. Now, the way this thing works, if you haven't seen it, is it focuses on the total amount of endpoints, the reauth interval, which does matter, and the DHCP lease period. So bandwidth is obviously different than latency. How we generate how much bandwidth is going to occur depends on how many remote sites, where we have the different nodes located. Now let's jump into scaling ISE a little bit better and look at, we'll start with radius and we'll kind of move down our subway map all the way over to optimizing M&T. So one big tip that I find happens more often than I'd like to hear is make sure you're not enabling unnecessary services. Like a good example of that is a ton of people will just enable thread-centric NAC even though they're not using thread-centric NAC. So those services do take up resources. Thread-centric NAC's a perfect one. It runs in a container. Those containers have resource reservations. So any of these services that are not in use shouldn't be turned on. And you'd be surprised, a lot of deployments I've seen, someone just goes through and checks everything, even though they're not using everything. So avoid if possible. The other thing that's important is the use of load balancing. And when we talk about large-scale, highly available ISE deployments, load balancers are pretty important to this. And I'm going to cover this quite a bit in the high availability section. So we're going to go into some pretty grave details on load balancing for all the different PSN services. Authentication policy optimization. We do see over time, as deployments grow, authentication and authorization policies seem to grow too. And if you're not careful, as you're adding more and more rules, you can end up with some bad rules that sit there that actually affect the overall global deployment. And this is one where you look at a sample rule like this, and we've got an external check with MDM that's happening every time before we ever evaluate a local piece of condition or criteria. So order does matter. All of the rules are top down, including inside the conditions. So as I evaluate this rule, instead of just checking whether it's an Android device first, I'm going to check with MDM whether it's registered, and I'm also going to check with AD first. And then if it's a Windows machine or an iPhone, I've done all of that work, and then I go to the next rule. So how we create these rules matters quite a bit. And this can change the performance on a global ISE deployment. More specific rules generally at top. Try to place the popular rules before less used rules. And another few examples with this is just being able, I like this example even better, which is within authorization, same occurs. We're going outbound first and checking external directories before we're checking things that are directly within the authentication method. So this is a very, very bad rule. Why? Because I'm doing a bunch of external checks before I ever actually see whether condition matches. To do this successfully, I can flip this around. So I'm going to check for a location, auth method, endpoint profile. Why do I check those things first? All of that data exists directly within the PSN. I don't have to go anywhere. After that, I can then start to do things like externally look up AD groups and attributes, check for certificate attributes, and then finally go to an external MDM or SQL database. So just try to structure the rule in a way that makes the most sense. Just like a firewall rule, too. You would never want the rule that's going to be hit the most 200,000 lines down. Now in 2.4+, we did increase the size of the policy table. So in 2.4, you can have up to 200 different policy sets. and you can have up to 1,000 authentication rules. Not recommending you try. And then also 3,000 authorization rules and 3,200 authorization profiles. Now, I'm going to show you some tricks where some people will create 100 authorization profiles because they're trying to accomplish differentiated access based on the user or device type. There are some tricks to kind of simplify the rule table as well. And we get into things like attribute matching. So instead of having 10 different rules for each individual DACL that you want to apply, you can instead use an attribute and populate it in the internal or external ID store and replace that within the profile so that you don't have to have 10 different authorization profiles. So in this example, I'm using the internal directory or an internal user and mapping the user DACL from that profile. You can also pull from AD and LDAP as well. So for example, if you wanted to match or name your DACLs the same thing as your Active Directory security groups, we can then take and have one authorization rule and assign different DACLs for those different security groups. The same thing goes for things like VLANs or any attributes within ISE authorization profile. We can do this external or internal lookup to replace. And this saves quite a bit, because normally the reason why we have all these rules is so we can differentiate access for DACLs or VLANs or other criteria. The other thing that can happen if you do have a lot of internal users, all of these attributes can be updated via an import or ERS API. So like the example of using the ACL right on the user account that's built into ISE, it can be done through API. Within external directories, you can actually use any of the criteria. In this case, we're using the zip postal code and putting the ACL in there. My favorite is to use something that's already in there, maybe organizational unit, security group, things that you're already keen off of, and now I can just make my DACL names match what's already in the directory. I'm good to go. There are some other quick tips on scaling when we get into ISE and authentications. And so little features that are kind of hidden back in settings, protocols. We can see things like EAP-TLS. So EAP-TLS session resume is pretty important. It actually puts a lot less load on ISE when you do things like cache the TLS and skip the full cert evaluation for every authentication. Same thing goes for things like PEEP settings. So PEEP session resume and fast reconnect actually take that processing load for every authentication if they are doing a session resume. These things do matter when you're talking about hundreds of thousands of endpoints authenticating, or even in medium-sized deployments. We now see an organization with 10,000 users. Really, 10,000 users can equate to 50,000, 70,000 devices because of the amount of personal iPad, iPhone. You've got earbuds that are connecting to wireless. So all of those things are big factors here. Fast reconnects allows us to skip the inner method. Like on the Windows 7, Windows 10, you'll see that option when you're configuring it. It actually helps save that processing load. Stateless session resume, very similar feature, just helping us skip full authentication processes every single time. Now we're going to talk a little bit about AD and LDAP and some of the enhancements and large-scale stuff that we've done with that. One of my favorites, and I'll tell this story, I was doing just a pilot for a customer, and I was deploying the pilot, and we were testing everything, and we ran into this issue where every fifth authentication would fail. Now, we figured it out pretty quickly, which was they had not customized AD sites and services, and so it was load sharing those AD requests. And so the fifth one was an AD server that was over a satellite link to a remote island. And that satellite link went up and down all the time. Now, from an administrator point of view, it would be very difficult to realize what was going on. As soon as you went into the authentication details, you could see which AD or the debugs, which AD was getting tried and then failed. But from a high level, it just illustrates the challenge with being able to rely on external services that are so critical to our authentication process. So AD sites and services allow us to respond with the local Active Directory server depending on where that ISE PSN is. And this is a big part of deployment design, making sure that if I have a PSN in site Y, it's going to ADY, and if I have a PSN in site X, it's going to ADX. Sites and services actually controls that, and without it, things can go a little haywire. And the other one that I've experienced has been people will delete a server within Active Directory and not remove it from DNS or remove it from the domain first, and so you have this AD server that exists that has challenges. A couple seats up front. Now, the other thing that we've done is actually we've added this AD diagnostics tool inside of ISE. And it's been there for a couple releases now, but if you're not familiar with it, it can actually help you do some health checking and make sure that the status of ISE is good, or status of our AD connection is good. And it will do things like check for DNS, A records, service records, the Kerberos check, and then an LDAP test to make sure that it's able to pull things out. Now, our customers really liked this feature, and what they wanted next was in 2.4, we added the ability for this to run every day and send customers that report. Because it was kind of reactive, right? Oh, there's a problem. Let me go diagnose Active Directory and see what the issue is. In this case, we can be proactive and run this diagnostic test, in the middle of the night or at a certain time, once a day, once a week, just to make sure everything is healthy and working. So that same diagnostic report that you have to manually run now does it automatically. Also in 2.4, we've done a little bit of enhancements with how we can check the health of the domain controllers and actually give it a preference score. And with 2.4, that scenario that I was describing for you, where AD server went away or the AD server is high latency and is not responding, the PSNs are actually smart enough now to realize I do not want to go to that bad AD server. Some basic best practices for you to take away with Active Directory: DNS matters, NTP matters. One of the things that I've found is all ISE nodes and AD servers need to be synced. If you don't have formal NTP, make sure that you point ISE to the AD server. If you have formal NTP, make sure Active Directory and ISE is synced to that same NTP server. Because I have seen it where the server team says, yes, AD is synchronized. The network team has a formal Stratum 1 clock. ISE points to that Stratum 1 clock, a delta of more than 1 hour, and now AD connection breaks. So just make sure that time is synchronized. I can't stress it enough. It's never a good day when people show up in the morning and they can't authenticate. Whitelist domains, AD sites and services, indexed attributes, and that new scheduled diagnostics is another new best practice there. From an LDAP point of view, it's not as native, but we have a lot of options on, for example, per PSN LDAP servers. So being able to map the PSN to the appropriate LDAP server that it needs to go to. And it allows each PSN to kind of map directly to the correct LDAP server that it needs to go to. So unlike Active Directory, where we have service records and DNS takes care of this, with LDAP it's more of a manual process. But we allow you to do that mapping directly versus what we do in sites and services for AD. You also can insert a load balancer if you want for LDAP, and that load balancer can help us send those requests to a single VIP and then be able to spread out those requests appropriately. Now jumping into scaling guest and web auth. So these are other topics that come up quite a bit. We could talk 2 hours just on these 2 slides that I'm about to show you, which is how do I take these web-based services and start to get global redundancy and scale? And the quickest answer is external load balancing that allows us to get additional services. Now, if we use a global load balancer or intelligent DNS, we can scale it out by basically listing all 3 of our PSNs under sponsor, all 3 of our PSNs under my devices, and allow that to actually do the load balance. Or we can go to a scenario where we have Anycast. And Anycast, if you're not familiar with it, allows us to take a single IP address, advertise it on multiple networks, and then allow routing and routing protocols to actually direct us to the fastest link or local system or resource. If you haven't read up on Anycast, it's going to come up quite a bit in this presentation. It's kind of your homework. Go back and read some articles on Anycast because it is a more common technique to allow for global redundancy and global scaling without having to have that external load balancer to do it for you. Now, when we're looking at scaling guest, another recommendation that's kind of out of the box, but I like to talk about it, is web requests are a lot harder to process and a lot more resource intensive than 802.1x authentications. So some of our customers made the decision for multiple reasons to leverage 802.1x for those guest authentications versus web authentication. And the primary benefit from an organization standpoint is when I do 802.1x for guest, all of my guests now are authenticating and then also encrypting on that SSID. So for me, that's big because now I have privacy between my guests and I don't have to worry about them being on an unencrypted SSID and the privacy concerns with that. The only downside to using 802.1x with guest is this concept of you can't give them AUPs or acceptable usage policies, and the password can't be changed because they're not going through that web redirect process. So you do have to watch out for expired guests, and otherwise you're going to get a high authentication failure count because guests came back, it's been 120 days, their account expired, that account needs to be renewed by their sponsor or by an administrator to get them back online. Remember me guest flows, so they do help as well. So we don't require the guest to go through that web authentication and redirect every single time they come into the network. A lot of times we see this with conventions or things like Cisco Live. You come in, you authenticate day one, you don't want to have to do it in 3 hours again, and you don't want to have to do it tomorrow either. So the remember me guest option actually helps quite a bit to allowing for those guest users to get on and stay on. Now we're going to jump into a little bit of tips and tricks for posture and compliance. So posture lease is a big feature that helps us with performance and scale. It can allow you to only perform posture assessment every X amount of days. And for me, that's big because I don't need to concern the user by prompting them or popping up any Connect posture every day. If they just came on, I can wait a couple days before I reassess the status. The other thing with posture, we start to talk about mobile device management and survivability of mobile device management. And so one of the things that occurs is you run into the down state and how we want to fail open for those authentications. So if you have an MDM server and it goes offline, do you want to stop BYOD completely? Probably not, depending on the organization, maybe. If you're a government organization and you require that to be up at all times, then reachability might differ. But the key thing here is we have this endpoint BYOD registration equals yes, so they've already been registered with BYOD, but the MDM server is unreachable. In this state, we can easily do a fail open and allow for survivability even though that MDM service goes down. Another one that has occurred before, while it's probably not that interesting for mobile users to have local internal Wi-Fi access without public internet access, is if internet goes down, maybe that user still wants to be able to communicate or get on. So those fail open options do provide a few use cases for that. Other thing that we've added in 2.4 is the ability to manage MDM attributes via the ERS API. So for those of you that are interested in using Python or Google Go or Perl to be able to interact with ISE, these attributes that MDM has within ISE, we can actually modify or manage directly from that ERS API. TACACS, how many of you running ISE for TACACS? Almost everybody. So, and most people, are now, I'd say we don't have as many ACS customers anymore. So the number of ACS for TACACS versus ISE for TACACS, I think, has pivoted. So we see more with ISE running TACACS than we do with ACS today. And the kind of key takeaways from thinking about TACACS with ISE and production scale is how you actually design this. So whether or not you want to run a separate deployment for Radius versus TACACS, or separate PSNs for Radius and TACACS, or run a mixed PSN, both running Radius and TACACS. Now, while this might be a little confusing here, the funny part about this is a lot of people that do run TACACS, they'll have administrative network access devices or administrative nodes that do only support Radius. So even though I say Radius or TACACS, and this is a green box for TACACS, potentially you're still running Radius, but Radius for device administration only. And that's kind of the key point there. But there is some pros and cons there that you can take away. I'm not going to read through them all for you. The key thing is making sure that you understand, how you would configure or enable the appropriate services depending on the design that you've created. So if you're running TACACS or Radius, the key thing here is policy services node has obviously required. This one, we're enable session services, which is Radius. TACACS is disabled. If we want to flip this, we can disable Radius services, and it's not as clear, and only enable TACACS on that policy services node. So a good way to kind of balance out. And a lot of times we do see this in production. Why? Because a lot of the management networks that we're running TACACS on, a lot of people still have out-of-band management networks where that Radius front end might be different than where we want to go to for TACACS. You also have to keep in mind scale. So as we look at adding TACACS or device administration to an overall global ISE deployment, we have to think of the max dedicated PSNs and how far that will scale depending on this hybrid mode versus dedicated mode. So again, we can have up to 5 PSNs when we have PAN and M&T co-located on a single node. There are a couple seats up front, 2 of them at least, if you want to come up. So up to 5 PSNs. So in this case, 3 PSNs running Radius, 2 PSNs running TACACS, or you can vice versa. So really being able to split that node. Now, other scale, M&T scaling, there is a big push for automation in every network today. So we're seeing more and more automation tools, provisioning tools, and there is a huge difference when we look at scaling both M&T and the authentication on ISE. And so the key thing here is whether it's a human versus a automated script device admin. For a normal human, we may expect 10 commands, right? And that 50 admins, maybe 60K of logs a day or 90 megabits a day, megabytes per day. With the automation, that type of automation, we'll see about 2.4 gigabytes per day. So remember that when you're running NSO or Prime or another that's actually doing an SSH login, sending commands, screen scraping, and then checking status. If that thing's running once a minute, it's going to generate a lot of accounting and logging that then needs to be stored. And so we've seen this before where already have Radius running, my global ISE deployment's good to go, it's been working for years. I add TACACS and M&T starts having performance issues. Well, when you start to uncover it, you realize that the amount of logs that are generated by automated scripts are actually, overcoming the performance of the M&T as scaled. And this is a chart that you can go back and reference later, just to give you the difference between that human admin, how many session and authentication and accounting, and then if we do add command accounting or command authorization plus accounting to the deployment, how different that is. So average, peak, logs per day, and then the storage per day. Now if we jump down, you can see how big that 4 scripted sessions per day, the number of NADs, so if we had 30,000 network devices and we had session or command and authorization, we're talking 4 gigs a day. Now, doesn't sound like a lot, but it adds up. 30 days pass, we're now at 120 gigs, and then we continue to grow and grow and grow. The other thing that's helpful in larger distributed deployments, if you've got a deployment that's based in Mexico City, but you've got nodes all over and network devices all over South America, you might need or want to limit the amount of connections that TACACS is using. And so not only does this help with basic logging troubleshooting, but it also helps with things like firewall logs, where I'm not showing 15 direct connections between TACACS and the NAD for every command authorization attempt. I'm only seeing a single connection and sending all of that data across that single connection. So that's what that enable single connect mode does, is it makes it so we establish one connection from the NAD up to the ISE TACACS server, and then all of the command authorization requests are going to go over that single connection. Now we'll jump into a little bit of profiling looped into database replication. Anyone know why we consolidate profiling and database replication? Because profiling is actually one of the largest contributors to database replication within the architecture. And so we're going to talk a little bit about how profiling affects the large-scale deployments and some best practices on how to get better scale because of the way profile replicates data. Just as a premise to make sure everyone's on the same page, you should all be familiar with how profiling in ISE works, but everything is based on conditions, and those conditions are matched up or calculated up to create a certainty factor. And so each profile inside of ISE has a minimum certainty factor, and in order for a device to be put in that profile, it has to meet that criteria. So if I do have an existing Cisco provided profile and the certainty factor is 30, and I have a new customer, custom profile that I add and the minimum certainty factor is 40, which one wins? Left hand or right hand? Someone point. Right hand. So certainty factor being larger always wins. So if it's 20 here and 50 here, we're always going to go. If this custom profile, if we set the minimum certainty factor to 20 and the certainty factor became 30, then the Cisco profile is going to win. Just remember, certainty factor is the higher, the better match, the more precedent of the profile that we're going to have. Now, a few best practices. We love to have these little check boxes in the UI and never have a really good description behind it. If you've ever been into Profiling Work Center, or gone to administrative settings and profiling, you'll see this little endpoint attribute filter. Now, by default, new deployments, it's checked. Hopefully no one unchecked it. Why? Because we're going to talk about what that actually does. And for me, this is a big thing for replication and how we do scale with ISE profiling. So by default, in early days, ISE 1.1, every single profile change would cause a global database replication. Well, what happened is we had a lot of ISE deployments just melt down because of the amount of changes and attributes that would actually change on a consistent basis. And so this was added maybe 1-2 time frame, so very early on. And what it did was took all of these profiling attributes that we have about host and create 2 new categories. One is what we call whitelist attributes. So these are the attributes that we're going to care about the most. And then 2, the significant attributes. So the biggest difference here is those whitelisted attributes are going to trigger node group updates and an ownership change. Whenever we see a change in any of these is when we're going to trigger a global replication change. If you've been working with ISE since 1.0 like I have, any of these things used to actually trigger a global replication change. Now in a lab environment, a couple thousand devices, not a big deal. Go to 50,000 devices, and that would cause a lot of havoc. So the moral is this should never be unchecked. Don't go in and accidentally uncheck it, because it's going to make it so every single profiling attribute creates replication across the entire deployment. So it's a very bad thing to uncheck. Now, if you haven't heard of node groups, this is how we start to control some of the replication changes that happen within ISE. And because profiling is a big part of those replication changes is why we link those 2 things together. But node groups essentially, by default, every system, every node inside an ISE deployment will actually send replication changes up to the primary admin node. When we add node groups, it starts to localize those updates. And so we basically see when a DHCP update happens between 2 PSNs, we can change ownership, we can keep that information replicating within the node group, but we're not going to update the entire global deployment until something significant happens. So that list of significant attributes, when those change, like a profile change, I'm going to go ahead and inform the PAN of this new update. Now the way this works is when I have multiple node groups, same thing. So I'm actually going to leverage those JGroup channels, and only when things like ownership changes happen will I send global replications. Now more for reference later on than for today, but some key best practices that I want to call out: do not send profiling data to multiple PSNs. So first thing that should be important, right, as we create those node groups and localization, you shouldn't be sending DHCP helpers if you have 10 PSNs to all 10 PSNs. At the maximum, you should do 2. So if one PSN goes down, you're able to send it to that secondary in case of, but make sure that you're not sending that data everywhere, because every time that data gets updated, if it is a significant attribute, we're going to see replication happen. So this actually affects that global deployment quite a lot. The other thing that's pretty big is device sensor. So if you haven't heard of device sensor, that's the ability for iOS or the wireless LAN controller to summarize up profiling data so that we're only sending attributes that we care about. Like in a DHCP request, there's a lot of data in there that really makes no difference for profiling. With device sensor, we'll pick off those attributes that are important, send them up in a radius accounting format so ISE profiling can use it without having to see the entire data packet or send it across your network. So summarization is important. Do enable the profiling attribute filter. I've seen people turn it off in labs or proof of concepts because they want things to replicate faster or they think it's going to be faster. For production, make sure that thing is enabled. Otherwise, you will see a ton of replication that is bad. From a probe point of view, there are a ton of best practices out there. Just to summarize, don't enable it unless you're using it. Avoid span, SNMP traps, and NetFlow probes unless necessary, unless you have a real reason to use those probes. And then limiting the PX grid probe to 2 PSNs max is another highly recommended thing. If you're not thinking about the replication and how sending data correctly, you should be. Load balancers depicted but not required. So you can use a load balancer to help with this replication and help with getting the probe data to the correct place, but it's not required to make that happen. So another example here is we've got our load balancer with Anycast and the DHCP request hitting a single PSN. If that PSN dies, then we're able to send it to the next PSN. So it does simplify our helper configuration out within the setup as well. A new feature in 2.4, if you hadn't heard of it, we have the Cisco Industrial Network Detector, which is a profiling device that can help in an industrial network specifically. Things like PLCs and other things that are on the network, maybe plugged into an IND switch that ISE traditionally wasn't focused on profiling. So in 2.4, we added PX Grid's ability to bring context into ISE. And that works pretty significantly with IND and some other third-party partners as well that allows us to bring those attributes into ISE for profiling with custom attributes. So when I say only enable that PX Grid probe on 2, the only reason why you would be enabling the PX Grid probe is if you had IND or another partner that you want to be able to use that data to profile with. You can see now in 2.4 that we have that custom attribute. That's what that's for, is using the PX Grid information. Now, MNT optimization and noise suppression. So one of the key things here is how many devices create different logs. And for me, we've got a guy who's been doing ISE scalability for MNT for a long time. His name's Clark Gambrell, and you can actually go watch his Cisco Live session that I'll put a link to in the next slide, specifically 2 hours on this topic. But one of the things that you should keep in mind at a high level is how we count or how devices behave matter for scale. And if you put licensing aside, we should really treat a wired endpoint as one device from a scale point of view. If it's a wireless endpoint, it almost acts like 2 devices. If it is a mobile device, we have seen the effects on performance be closer to 5x. And that's based on the amount of roaming, authentications, and authorizations that take place from that mobile device. And a good example of that is, we always call it, and hopefully you've heard this example before, early days of ISE, we had a kid on a skateboard at a university. And that kid on the skateboard had an iPad, an iPhone, a Nintendo. He had like 6 or 7 devices in his backpack. And he went across this campus, and the total amount of endpoints on that 6,000 endpoint campus actually created 10 million auths and 9 million auth failures in 24 hours. So if you think about that, that's a lot of logs. And so there are many configuration options that we have that can help with seeing this message. And no matter what, if you have ISE deployed in wireless, you've probably seen 1 or 2 of these. 5411, no response received within 120 seconds. This happens when the client starts authentication, but then stops responding. And when the kid on the skateboard goes from one side of campus to another, he hits 50 access points. All 9 of the devices in the backpack keep trying to eep, and never respond, it's 9 times 50 for just one kid rolling across the campus. So you can see how this can be a very big impact on monitoring and troubleshooting. Now the real question is how can we make this better? There's a lot of tools here. The first is really controlling timers on our network access devices. We also have the ability to focus on filtering on the PSN and on MNT, and I've got a few examples there as well. One feature that's big is client exclusion. So if you're not familiar with client exclusion on a wireless LAN controller, when it sees bad behavior, it can actually exclude or stop allowing that client to ever authenticate or connect over a certain time period. And so instead of having a few hundred auths or 1,000 auths in that second, we would minimize that down to maybe 2 or 3, and then the wireless LAN controller cuts it off. This was that session I was mentioning, the dynamic environments, Clark's session. You can go to Cisco Live online and be able to watch his presentation as well. And his presentation goes into a lot of these details for a full 2 hours. If you're not familiar, we've made it a little bit easier because people are like, I don't want to have to read a 10-page white paper to configure the WLC with ISE. So if you go onto the wireless LAN controller, as you're adding ISE, there's 2 steps. When you're adding your radius server, you can apply Cisco ISE default settings. And within your WLAN, there's also apply Cisco default settings. This is going to do things like turn on exclusions. It's going to set the timers to the recommended ones that we've come up with. So those are big. On the wired side, you will have to read a little bit, take this slide, or take the white paper and configure that way. On the ISE side itself, we still want to do features to help, even if we do have a misconfigured network access device. So if the first step is to get those access devices sending the correct information as much as possible, but even then we can still try on the ISE side to get too much data. And so on the ISE side, we have a few features that help us really add log suppression so that it's a more drinkable approach. So if you haven't seen this, you should have. In 2.2, we actually made some of these smart defaults. So the first one that's big is this repeated failed clients. So if I fail, I don't need ISE to log this every single time. Take the first copy, and if nothing has changed except for they tried again, add a counter on top of it. And the same thing with alarm statistics, with the timing, as well as the repeated failed radius requests. We can actually hard code this, so failures prior to automatic rejection up to 5 over a period of time. Now the other thing is ignore repeated accounting requests. This actually helps us if the NAD is misconfigured. So if it's still sending us too much data, we can actually ignore them for the same session. And then finally, same thing for successful authentications. Even if we do have our NADs tuned correctly, maybe I roam a lot, I'm in a hospital environment. This will actually allow me to use a counter versus having a new authentication and having to log that every single time. I mentioned client exclusion, how important that is. When we get into the way this thing looks, you do see how these repeat counts actually update based on fails and then based on allowed devices or repeated authentications. Now it does come up sometimes when you're trying to troubleshoot a device. Hey, I have this new device, it's failing a ton of times, I need to be able to see what's going on. And this is why we added the bypass suppression filtering for 1 hour. So I can see every authentication and whether it's real. Now you saw a few of those settings actually said reject this client and don't allow it to come back into ISE. That causes other issues. Hey, we need to be able to get rejected clients online. So you'll see on the ISE dashboard, rejected endpoints. These are the hosts that have been rejected, and you can go in and actually allow them back in. All right. So we'll probably be able to get through a couple of these load balancing slides, and then I'll take some time for questions as well. So when we get into node redundancy and high availability, the biggest thing here is going to be load balancing and how we configure automated failover. So with the PAN, starting in 1.2, it's been around for a while. The key thing is that we allow for the PAN to actually automatically fail over from the primary to the secondary. Now, in order for that to occur, we have to have some external health node systems. Typically, this is done on external M&T nodes or PSNs to do that checking of the devices. The other thing that happened in 2.6, along with that lightweight directory service, is we changed the way we do logging and switched over to RabbitMQ. And what this fixed for a lot of customers was the ability to buffer. So as the WAN goes down, it used to be UDP, we would lose log messages. With this RabbitMQ architecture, it allows for buffering. The only challenge is today, if you are a large, when I say large, above 50,000 devices, it's still recommended to keep that disabled until the future version where we're starting to scale it out a little bit more. All right, how many of you have ISE with a load balancer today? Okay, no one. So the load balancer for services is kind of critical in the sense that it helps simplify what happens with our PSNs and how we communicate with them. One of the key benefits of having the load balancer is things like upgrades. Like everyone hates upgrades, they take a while. When I get into this architecture, I'm able to make a change on the load balancer, take this one PSN out of service, upgrade it, bring it back into service, and do the next one. So we're talking about very simple, easy or zero downtime upgrades. The other key to this is our network access device configurations really are simplified. So instead of pointing to a primary and a secondary PSN, or having to have a different configuration so I do get load sharing across my PSNs, I point to a single virtual IP and I'm done. And so in order for this to work successfully, we use the node groups within the PSNs to be able to assign a group of PSNs to be able to be load balanced. And what this does is allows for those 3 PSNs in this example to communicate and replicate session data directly with one another. Now, at a high level, typically this is deployed where I've got a VIP on the outside, I've got my PSNs on the inside, and when we look at how we want to do this, it can be physically separated or it can be logically separated. There are a few other options in here. Typically, the customers that are deploying this either have load balancers on site, or there are options and examples on Cisco's website for some of the tools that are native within the network architecture. So things like iOS server load balancing. We have a feature on Nexus called Intelligent Traffic Director, which is a load balancer as well. So there are ways to get to this type of scenario, even if you're don't need to invest or don't have F5 or Citrix or another of the larger load balancers in your environment. Now, from a sample topology and flow, what happens is I start to use this PSN VIP domain name and a single IP address for access requests. So whether it's radius is going to look pretty simplistic. I've got one radius server, it's going to hit the load balancer, and then response goes back through the load balancer so that we can NAT. So source NAT happens from here up through the load balancer so that the request comes from that same IP. This is where things get a little bit more complex though, because we need stickiness. If you're not familiar with load balancers, if you don't have stickiness, one request comes from here, it could go to PSN 3, the next request could go to PSN 1, and that kind of behavior for client authentications is not good. So we'll talk about that in a second. with stickiness, the key attributes that we're looking for is the ability, in most cases, to look at calling station ID or framed IP address, or more specifically, we could use the radius session ID to lock in the correct PSN for every session. And this does change a little bit depending on whether it's radius or we're doing web authentication, and I'm going to give you, I've got a few of those examples later on. Last thing I want to call out, calling station ID as the primary. So if we can use calling station ID, it's going to be the best bet. So for this MAC address, authenticating up, I always want you to go to PSN number 3. And it will create that stickiness over time. Another thing that happens, if you are doing certificate authentication, EAP TLS, EAP TTLS, PEEP TLS, you've got client certificates that are being encapsulated in radius. Well, sometimes they get very large, and it can cause IP fragmentation. And so you do need to address fragmentation in the load balance design, because the fragment 1 is going to have that calling station ID. Fragment 2 doesn't have calling station ID because it's been fragmented. Now, most load balancers can do this reassembly so that we don't run into the issue. But the key thing is making sure that you understand when fragmentation might occur for those radius packets, for large packets, and making sure that fragment reassembly is enabled for the load balancer. ISE web services, very similar. Since no one's doing it as much, I'm going to skip forward a little bit because I know we're running out of time. While I'm skipping forward, anyone have any questions? All right. So I did want to take a couple minutes and talk about monitoring and load, because since you aren't doing load, most of you aren't doing load balancing today, all of that is well documented. You have the PDF. I do recommend you look at some of the options because it can simplify upgrades and increase scale for production deployments. And it is kind of the recommended deployment for larger deployments. When we talk about monitoring load and system health, you should hopefully be pretty familiar with the server latency widgets within ISE and our ability to kind of measure latency. So when you start to see things like it go above that 300 millisecond between PSN and PAN, those are the types of things that you're going to see alarms on, and you should be monitoring. The other key thing here with load is looking at process and disk space utilization, so you can start to see those trends. Like on M&T is probably the most common one, where people don't realize that they're just operating and don't have enough disk space. So they deployed a 600 gig VM, and in reality they should have 1.2 terabytes or up to 2 terabytes for their deployment. The other key performance metrics under operations, reports, diagnostics, KPM, you can actually start to monitor and track radius load, latency, and suppression stats. This is all going to help you kind of keep track over time of the deployment. Now, one thing I talked about early on in the day was this concept of platform size. So you can see the platform size in reports, and you can start to use diagnostics ISE counters to do specific node details. So for example, endpoint ownership change, how many of those profiling changes am I seeing in my specific PSN that's doing that platform? Now, just to bring it all home, some of the key takeaways for this session, and again, I know I talked very quickly. I'm sorry. If we had 3 days, we could continue to go over tons and tons of these details. But some key takeaway points: check ISE virtual appliances for proper resources and use that platform detection to make sure you're within the scope. This I've seen way too often. We need to make sure we get a handle on the VMs and the resources. Avoid excessive auth activity through proper NAD and supplicant tuning and log suppression. Don't drink from the fire hose. You want to be able to control that a little bit better. And the tools are there. It's just a matter of making sure you check everything. And one of the challenges that I think a lot of organizations run into is helping automate those config changes and getting consistency. Because if you have 100 different network switches that are doing radius and half of them are configured correctly and the other half aren't, that's half of the battle, I think, is making sure there's consistency across. Minimize the data replication, implementing node groups and profiling best practices. Again, I had 2 very important slides that had those summaries. Don't send the same data to multiple PSN or all your PSNs. Make sure you're understanding what's causing profile changes and replication. Load balancer, since no one's using them today, I really highly recommend you look at them, at how they can be leveraged and how they can be used. And even if you don't want to spend money on a load balancer, like I said, there are some good out-of-the-box networking tools like Intelligent Network Traffic Director, ITD on Nexus switches, as well as iOS server load balancing, and we have some of those examples up on Cisco.com. So you can see how they work with those radius flows, how they work with profiling, those kind of things. Finally, be sure to have a local fallback plan on your network access devices. Make sure you have that either a VIP with a load balancer or you're appropriately scaling and having the fallback. So primary, secondary, potentially tertiary as well. With that, like I said, there's almost 600 slides in here. We could spend all day. There's a reference version that you can download. The load balancing guides are up on that CCO site. And also we have the calculator for bandwidth, performance and scale, and an HLD template. So please use the resources. I do a lot of different Cisco security tools, and ISE is actually one of the best documented ones as far as examples to help customers do this well in production. We do our best at keeping them up to date as well. This is the most comprehensive one. So all the links to feedback, ISE resources, community, compatibility, all of those things are there for you. One last plug, if you haven't seen the endpoint analysis tool, it's a free tool that you can use that helps with profiling and helps your profiling deployment. So you can go to eat.cisco.com and sign up, and you're able to actually link it up with your ISE data, and it will help you look at the profiled endpoints and help you manage unknowns a little bit better. Finally, please fill out the survey. We take them very seriously. My boss always jokes, if I don't get a 5, I'm bad at my job. They kick me out. And with that, we've got about 12 minutes for questions, so I wanted to leave appropriate time. Any questions? Yes, sir.
So just wondering if there are any known issues, if you have seen any issues with ETLS authentication running on Windows native platform versus using a NAM module.
Say that one more time. Which kind of authentication?
ETLS.
ETLS running on
The native client for Windows.
native client for.
Versus using the NAM module.
I don't think we've done a comparative analysis. So the question, if you couldn't hear in the front, was a comparison between native supplicant on Microsoft or Apple versus the AnyConnect NAM, which is Cisco supplicant. I don't think we've done a performance analysis on what is faster or if there is any difference between the two. The biggest one that you have to remember is TLS size, so the certificate size does matter. So if you generate a 4096-bit certificate and you're sending that for ETLS versus a 2048, there is a difference in size and a difference in processing that it takes.
To that point, the features that you introduced in 2.6, you need the AnyConnect to have the, you need the AnyConnect to have the UID.
So the UDID was focused on posture specifically, not necessarily on using the NAM. So The UDID feature is a part of the posture service of AnyConnect and not necessarily a part of using AnyConnect NAM for that. Great question, though. Other questions? I know someone has a bleeding question from their deployment that they want to get answered. If not, I will hang out here. I can let everyone run that needs to go, and I'll hang out and answer questions one-on-one. Thank you, everybody. Oh, one more.
Can you share the link for the presentation?
Yes, so it should be within the Cisco Live tool. You should be able to. You can't get to it? Okay. The last thing then I will do, I will put the link in the WebEx Teams room then, which you should be able to get to. The last thing I will do for you, though, just in case, is I'm a big fan of making sure everyone can get a hold. Let's make that big and make the background white and bigger. That way, if anyone wants to reach out directly, they can.
They're not posted yet, so I can't.
Okay, so they're working on posting them. It should happen in the next few days. This session wasn't recorded, but I believe the slides will be up on the global Cisco Live site as well, so you can get them in probably a week or so as they post them. If you need something quicker, then drop me an email if you have questions afterwards. Happy to take questions after the fact, too. Well, thanks, everybody. Enjoy the rest of the event, and enjoy ICE.